Welcome back to my channel. I am Dr. K. In my previous video, I promised to show you how to determine the hybridization of some compounds. So that's exactly what we'll be doing in this video. I'll be telling you the secrets for getting the hybridization of a compound. So if you come across a compound, for example, let's say sodium hexafluoride SF6. So how do you know which type of hybridization it has? So now that's what I will be doing in this video. So let's go ahead and do it. So I have some compounds here which I will be doing the hybridization and how it looks like. To be able to check the hybridization of some compound, as I said in the previous video, you need to know the central elements. Are you getting it? Central element. So, and the central element is usually the element that comes first. That's the central element. So then the other element attached. So you have you have issue mostly with the central element. Are you getting it? So the other element bonded to the central element. So we just we just add up to it. But the main work is on the central element. So that's what I want you to know. So let's go ahead. I'll be showing the hybridization of many compounds and even some compounds that have unusual hybridization. So the first compound I have here is AlCl3. AlCl3. Now, how do you determine the type of hybridization in AlCl3? Now, what you do is this. This is the central atom Al. So you know to know the the atomic number of Al. Are you getting it? So the atomic number of Al is 13. Yes. So what do you do about 13? Then if you want to set it up, the electronic configuration will be 1. It will be 1s2, 2s2, 2p, 6, yes, 3s, so 6, 10, 6, 2, 10, 13, 3s, so 6, 7, 8, 9, 10, so 3s2, yes, 3p1. Are you getting it? 3p1. So that's that. So 3s2, 3p1. So we only have issue with this 3s and 3p. Are you getting it? So now let's go. Let's do the electronic configuration of AlCl3. What do you do? So draw your orbitals. So this is your okay. Let me draw it here. So we are doing for AlCl3. Okay, let me do it properly. So now this 3s, this is your 3s here. 3s2. Are you getting it? So 3s orbital. Then this is your 3p orbital. So you have it. Are you getting it? So this is your 3px, 3py, 3pz. Are you getting it? So anywhere you see 3p, this x, this y, this z. So let's go. I wouldn't go into more details. Are you getting it? So I'm showing you just the secrets. So I don't want to go into unnecessary details here. So what you do now, this is it. 3s, it has 2 electrons. Are you getting it? Just put it that way. Then 3p, it has 1 electron. Are you getting it? Put it that way. Are you getting what I'm saying? Now let's go. So normally if you want to do it, you will have to promote 1 electron here. Are you getting it? Promote 1 electron here. Are you getting it? Then the cell will now bond to it. Are you getting it? But this is the secret. So in order to be able to do it fast, so what you do is this. You have AlCl3. You have AlCl3. So now you know. So just count your number of chlorine. That's 1, 2. You have 3 chlorine there. Yes. So just take it as if it's an electron. Are you getting what I'm saying? Now put it this way. 1 is here. 1 is here, making 2. Another one here, making 3. So can you see now? So can you see now making 3? 1. So making 3 altogether. 1 here, 2, 3. So this is why you are. So in AlCl3 now, what we have is AlCl3 as sp2 hybridization. sp2. Can you see? So you have this because it affects only this p and this p. Are you getting it? So sp2, s, that's 1s, then p2, 1, 2, 2p, sp2 hybridization. So that's that. So that one gone. So let me do the next one. The next one is the configuration of BF3. BF3. So BF3. Now look at the BF3 here. This is the BF3. BF3. Want to do the configuration. Now how do we do it? Now BF3 is boron. It has atomic number of 5. Now what do you do? So if we want to set up the configuration of boron, this is how you do it. It has atomic number of 5. So it will be 1s2, 2s2, 2p, 2p. So atomic number of 5, 1s2, 2s2, 2p. So this it will be 2p1. Are you getting? Are you following? So now you have issue between your, it's usually between S and P. Are you getting? It's usually between S and P. So in order not to waste time, so take this as your S. So this is your 2s, then this is your 2p. Are you getting it? This is your 2p. So now your 2s contains 2 electrons already. Are you getting it? So this is your 2p. So now your 2p also contain 1 electron already. Now count your fluoride. That's 3. Are you getting 1, 2, 3? So just put it 1, 2, 3. Are you getting it? So what you have is px, py. Well, so you have sp2. This p1, p2. Are you getting it? That's how you have sp2 hybridization in BF3. So having established that, let's go. So now let's talk about the third question here. That I want to talk about the next one is PCl5. So hybridization. Okay, we have a compound PCl5. How do we go about it? So this PCl5 here, PCl5, PCl5. We want to determine the type of hybridization present in PCl5. Now the central atom here is P. That's phosphorus. So it has an atomic number of 15. So now how do you do it? So you have 1s2, 2s2, 2p6, 3s2, 3p3. Are you getting it? 1s2, 2s2, 2p6. So 6 plus 2 plus 2, 10, 12, 15. Are you getting it? So this 15 altogether. So now that you've gotten your 15, then you have issue with this 3s2 and 3p3. Are you getting it? So let's go. So 3s2, 3s will give us what? Let's do it like this. One. Now this 3p, 3px, 3py, 3pz. I'm coming. Okay, now let's go. So now this is the next thing. 1, 2, 3s2, Abi. So 3s, 3p, that's 2 electrons. So 3p3, I said 3p3 the other time. So what you do is this 3p3. So according to one's rule, it will go 1, 1, 1. Are you getting it? But based on this principle I'm teaching you, so in order to save your time, so just bring it together. 3p3, Abi, am I right? Yes, 3p3. Okay, 3p3. Now this 3p3. Now we have how many chlorine here? 1, 2, 3, 4, 5. We have 5 chlorine. Are you getting it? Now, one occupied here, another one here, another one here, making 1, 2, 3. 3 has entered. Are you getting it? Now it's remaining 2. Here will the 2 enter. Are you getting it? There's no way for the remaining 2 to enter. So that means you need another 3d orbital. Are you getting it? You need another 3d orbital. So when you put another 3d, are you getting it? Now 3d 1. So 3d has how many? I think 5. 1, 2, 3, 4, 5. Now can you see? Now 3d. So it remains 2. Am I right? So now this one chlorine here, another one making 2, another one making 3. So it remains 2. So one will occupy here, another one here. Are you getting it? So this is 3d. So 3d, let's say 3dx. Are you getting it? So now can you see now? It's freed up to 3d. So you have S, P1, P2, P3, and 1d. Are you getting it? SP3. So S, that means 1S, 3P, and 1D. So that's why in PCS5 it is SP3D hybridization. Are you getting it? SP3D hybridization. So that's that. So having done that, let's find the abbreviation of another compound. after finding PCl5, okay, let's find for XeF4 also. XeF4, SF4. Are you getting it? XeF4. So this is it. Sulfur it has atomic number of 16. Are you getting it? 16. So if we are to configure it, we have 1s2, 2s2, 2p, 2p6. Are you getting it? 1s2, 2s2, 2p6, 3s2, 3p. So what do we have? The 6, 10, 12. And we said it has an atomic number of 16, Abby. So which means P will only take 4. Are you getting it? P will only take 4. Okay, now let's go. Now that we've gotten this, now let us do, so our we have issue with this 3s and this 3p now. Are you getting it? Now let's do the normal configuration. So 3s2, let's write it there. 3s2, 3p4. So let's do it. This is your 3s. Okay, let me, so because of one, so 3p, okay, 1, 2. Are you getting it? So 3s, 3p. Are you getting? So now 3s has 2 already. 2. Yes. So we have 3p4. That's 1, 2, 3, 4. Are you getting it? So now how many we are dealing with? Don't forget we are dealing with XeF4. XeF4. So we have XeF4. So it's XeF4 we are doing 4. So now let's count. So we have 4 fluorine here. 1, 2, 3, 4. So let's put it 1, 2. Are you getting it? Can you see it remains 2 for it to occupy? Are you getting it? So we have to create another 3D. Are you getting it? So it will occupy the first part of the 3D. That's 1, 2, 3, 4. Are you getting it? So P1, P2, P3, S1. So we have sp3d. Are you getting it? sp3d. Had it been another discovery, it would have sp3d2. So take note of that. So let's move to, now that we've done that, 1, 2, okay, let's move to the next one, XeF6. That's the next one we are naming XeF6. Now this is it, XeF6. The central atom here is sulfur. Also, the central atom is sulfur. So now in sulfur, the what we do is the same way we configure the other time, that we have 3s2 and 3p4. So in order not to waste time, let's continue from there. That will be S 3s. Okay, let me put 3p. Okay, this is my 3p here. 1, 2. Are you getting it? 1, 2. So 3px, 3p, 3p set. So let's put it. So 1, 2. Let's put it in 1, 2, 1, 2, 1. Okay, 4. Am I right? So 1 to 4. So after we have put 4, what's the next? 3s to 3p4. 3p4, 4 electrons, 1, 2, 3, 4. So now let's start putting those 6 of this. So 1, 2. Are you getting it? So 1, 2. It remains 4, Abby. So we have to create 3D orbital to occupy it. So we have 3. So this is your 3D. So when you put it, how many can you occupy? So don't forget 2 will enter each. So 1, 2, 1, 2. Are you getting it? Now look at the 3D. Let's say this 3dx, 3dy. So now what can we say from here? We have 1s orbital. That's s. So 3p here. P 3, 1, 2, 3. Then d 1, 2. So sp3d 2. So in XeF6, the hybridization is sp3d2. So that's that. So that one gone. Now look at this. We'll talk about this. So now let's talk of the okay, let me leave for, I want to do for xenon, XeF4. Now look at it, XeF4. So XeF4 is also, it also follows the same principle. So just that what you do here, you know the valence electron of XeF4. We have 5s2 and 5p6. So that's what you have. You have 5s2 and 5p6. So now what do you do about it? 5s2, 5p6. So just put your draw your configuration. This is your, look at here. This is your 5s. This is your 5p and this is your 5d. So let's divide 2, 3, 4. Yes. So 5p1, 2. Now you have 5s2. If you check the configuration, 5p6. So that's 5s2 and 5p6. So when you now start putting your 2, one here, another one here, are you getting 5s2, 5p6? 1, 2, 3, 5p6. No, can you see now? So now you can see that there is nothing else to for it to occupy here again. Are you getting? There's nothing else to occupy here again. I mean, there's nothing. This place is filled up. So and where we fluorine enter, it has to enter another 5d orbital. So when you would put the 4, 1 here, 2, 3, 4. So when we put it all together, what we have is sp3. Are you getting it? Then 5d orbital, the 2, d2. Are you getting it? Because d was filled up here. So that's about XeF4. So it's just about knowing the valence electron in the orbital. So the next one is, after we have done that, now let's move to the next one. Now we want to do the hybridization of some unusual compounds, that have unusual hybridization. So let me start with our NH4 plus. So let's talk of NH4 plus. NH4 plus, can you see? So NH4 plus, in NH4 plus, the central atom is nitrogen. Nitrogen has atomic number of 7. Are you getting it? So if you have to set it up, it will be 1s2, 2s2, 2p3. Are you getting it? So 2 plus 2 plus 2, 7. So that's it. So now we want to write for nitrogen plus. Now set up the configuration. So we have issue with 2s and 2p. Are you getting it? So now let's go NH4 plus. So you just write. So this is your 2s. This is your 2p, 1, 2. Can you see this is your 2p? So now when you put it together, 2px, 2py, 2pz. So when you put it together, so let's not waste our time. We have an issue with 2s and 2p. So that will be 1, 2. Can you see? So 2p3. So let's occupy it 1. So without wasting time. So 3. Are you getting it? And we are dealing with NH4 plus. Are you getting it? Now, do you know what you will do next? Because this H4 is carrying plus, subtract 1 hydrogen from it. Are you getting? That's the principle. Subtract 1 hydrogen because the H is carrying plus. So what do you when you subtract 1 hydrogen, you have 3 hydrogen left. You have H3 left. Are you getting it? So you just count 1, 2, 3 and put it 1, 2, 3. Are you getting it? So then you have sp3 hybridization. You have sp3 hybridization. So in NH4 plus, you will have sp3. Are you getting? So when you're having plus, you subtract. You subtract. So let's go. So let's do the hybridization of H30 plus. H30 plus. Now H30 plus. H30O plus. Now the central atom here, hydrogen cannot be the central atom. The central atom here is oxygen. Are you getting it? Now oxygen is that atomic number of 8. Are you getting it? So you want to set it up, it will be 1s2, 2s2, 2p. So 2p4. Are you getting it? 2p4. 1s2, 2s2, 2p4. So let's write it normally. So this H3, we are dealing with H30O plus. So 1s2, 2s2, 2p plus. So then you have, so let's set it up. We have issue with 2s and 2p. Are you getting it? So 2p. So 2p x, 2p y, 2p z. So what you do is this, put this. So 2p and okay, this is your 2s. 2s contains 2. So put the 2, then 2p4. Now 2p 1, 2, 3, 4. Are you getting it? Now, what do you do now? Look at the oxygen, it's carrying plus. Because it's the one carrying plus and it's the central atom. You will not remove one from it. What you will do is just that, remove one electron from it because it's carrying plus. Remove one electron. Are you getting it? So so you are supposed to have 4 here, 1, 2, 3, 4, but remove one electron. Are you getting it? So you have 3 electrons left because of the plus is carrying. Are you getting it? So when you now start putting your H, you have how many H? 1, 2, 3. So put your H. So put your H here 1. Put your H here 2. Another H here 3. So hybridization in H30 plus is sp3. Are you getting it? sp3. So that will be all for now. So I want you to please take notes of this hybridization, even the ones carrying sign, how you do it. I've given you the principle here to make it fast in any exam that you can come across. So that's the principle. So now before I go in this video, I would like to give you an exercise. So I want you to find the hybridization of MnO4 minus. There will not be enough time for me to do that in this video, but your comments will be appreciated. MnO4 minus, and the hybridization of what? FeCO5. Are you getting it? MnO4 minus and FeCO5. I want you to find the hybridization. So any solution you get, leave it for me in the comment section. Thank you for watching, and God bless you.